So we're solving systems of cost equations. Over the weekend, families rushed to the theaters to see the summer blockbuster Sharks. All tickets were sold at the box office. Child tickets cost $6 each. Adult tickets cost $10 each. Total revenue collected was $1,500, and 200 tickets were sold. How many child tickets were sold? Let's focus on this first question first. So we're going to, one, identify the two unknowns and make them variables. Obviously, we don't know how many child tickets were sold. We're going to make that a variable. Then, we know the cost of child tickets, and we know the cost of adult tickets, but we also don't know the number of adult tickets sold, so we'll call that Y. Now we can create two equations based off of the totals. So I've got total revenue, and I have total tickets. So the first total equation will be a tickets equation, and the second total equation will be a revenue equation.
Good, so let's go ahead and create these equations based off the totals, and when you create it based off the totals, you're just setting it equal to the total. So for tickets, what was the total number of tickets sold? It was 200, so we can set it equal to 200. Well, we don't know how many child tickets were sold, but we know that the number of child tickets plus the number of adult tickets that were sold equals 200. So there's our ticket equation. Now our cost equation, our revenue equation, we know that the total was 1,500, so we can set it equal to 1,500. And then we know that the number of child tickets times $6, so $6 times the number of child tickets sold, plus the number of adult tickets times $10 each, since they each cost 10, added together should equal 1,500. So now we have our two equations. We can go ahead and move into the third step. We're going to use a calculator to help us graph this. So all we need to do is solve for y. So here I need to use inverse operations to eliminate the x term on the left side. Those are gone. Now we have y. Since it's positive, we don't have to do anything else. 200 minus x, we can go ahead and leave it in this form because all we need is y equals. Let's do the same thing with this equation. We're going to eliminate the x term first, but using inverse operations. Those are now gone. And now we have positive 10y. We've got to eliminate the 10. Since it's being multiplied, we're going to divide both sides by 10. Make sure you divide both these terms. Okay, 10's divide to, sorry about that, 10's divide to 1. We have y left, 1,500 divided by 10. Since we're putting it in the calculator, I can actually just leave it like this. And negative 6x divided by 10. So both of these equations are now ready to be graphed.
So again, if you want to simplify this because you're like, oh, I know how to simplify and reduce, that's fine, you can do that. Every calculation you make gives you another opportunity to make an error. So the less calculations you make before you put in the calculator makes it more likely that you'll get it right. So again, every time you divide or you reduce outside of the calculator, if you accidentally mess up, it's going to give you the wrong answer. That's why we're not reducing. That's why we're not rearranging. So we've got our approved calculator here, and we're going to go ahead and put in these two equations and look for an intersection point. So that's going to be graphing. I'll use the graphing tab. And I can go ahead and just type in here, y equals 200 minus x. For the other equation, I can go ahead and type in 1,500 divided by 10 minus 6x divided by 10. I'll just double check everything's right. 200 minus x, 1,500 divided by 10 minus 6x divided by 10. And I am at a point where I can go ahead and graph this. So I graph it, nothing's showing up here. So I'm all the way zoomed out, nothing's showing up. I need to adjust my window. When I go to adjust my window, I know that we're looking at child and adult tickets, so I'll just make it whatever the total is for adult tickets. So my maximum number of tickets that I can have is 200. The minimum number of tickets that I can have is 0. Again, for the y-axis, which is adults, 0 tickets is the minimum number. 200 is the maximum number that I can have. And once I've put this in, let's go ahead and see what the graph looks like. So I can see way down here, I've got an intersection point. I'm just going to go ahead and zoom in. So I can see that the point's hitting the x-axis around 119. Around 119. To verify that, I go to my table. I say that I want to go ahead and begin my values at around 119. I apply that. And now I'm looking for the y values to match. I've got my x values here. I want my y values to match. 8178, 8078, 79, 77, 78, 76, 77, 76. I can see they're getting closer. 76, 75.6, 75, 75. So here it is. When my x is 125, both of my y's are 75. That is our solution point. Because this is our solution point, I know that x equals 125. And y equals 75. X is child tickets. So how many child tickets? 125. Y is adult tickets. Did they ask for that? No, they didn't, so it doesn't matter. So we have located the point. We verified it in the table. There is our answer.
Good. So now we can jump into just question number 2. And what it's saying is, assume that the number of tickets sold would not change. So they sold 200 total, right? How much would the theater have profited if each ticket cost $10? So if they sell 200 tickets times how much it cost for each ticket, we multiply these two, then we'll get our answer. So 200 times 10 is 2,000. We just add the 0. If I use a calculator, I just punch in 200 times 10. So we know that the theater would have made $2,000 if they sold each ticket, both child and adult, for $10. Now that we know how to use the calculator, we're going to go ahead and go through these examples a little bit quicker.
So we can go ahead and just start underlining key information here. Over the weekend, families rushed to the theaters to see summer blockbuster Sharks 2. All tickets were sold at the box office. Child tickets cost $3 each. Adult tickets cost $5 each. Total revenue was $3,000, and 800 tickets were sold. That's the total number of tickets. How many child tickets were sold? Okay, well, we know that we have to identify our variables. We don't know child tickets because that's what it's asking for. We'll label that X. We don't know adult tickets. We will label that Y, and we can begin to create equations based off our totals. We have total revenue, total tickets. So we have a tickets equation, and we have a revenue equation.
Okay, so let's set our total number of tickets equal to 800. And we know that the child tickets plus the adult tickets will equal that. And then our total revenue we know is 3,000. And we know that the cost for each child ticket was $3 plus the cost for each adult ticket is $5. Now that we've got our two equations, we can go ahead and solve for y. So this first equation, we're going to eliminate x by subtracting using inverse operations. It's gone. We have positive y, so y equals 800 minus x. Good there. Now let's solve for y here. We're going to eliminate the x term by subtracting. And we've got 5y. These are zeroed out. Plus 5y. We can go ahead and divide to eliminate the multiplication using inverse operations. We'll divide each one individually, and then we'll write our new equation. We have y equals, I'm not going to simplify this even though I can, because I'm going to let the calculator do that for me, backslash, and then when I write this, I'm going to write x in the numerator.
We're ready to plug it in. Now, when we go to our expressions here, we have our old expressions. We need to make sure we delete those, or we'll have some confusion in our graphing. So we go ahead and we delete those old expressions, and we type in our new expressions. We now have 800 minus x. And we also have our second equation. I'll just move this up a little bit to see it. 3,000 divided by 5 minus 3x divided by 5. Our total tickets are 800, so let's go ahead and adjust our window right now and say maximum tickets we could have are 800, minimum is 0, and again for the y-axis, maximum number of tickets we could have is 800, and the minimum is going to be 0 still. So now we've got that, let's go ahead and jump into our graph. Boom, we've got a nice intersection point. It looks like it's around 496. Let's see if we can zoom in a little bit, see if we can do better. Okay, a little less than 504. So let's go to our table. We'll type in 504. We think it's a little bit less.
And we're looking for the point where the y value is the same. And see, he's highlighted it right now where x is 500, the y value is 300. We know that's the point that they're crossing, so we know that's our solution.
And again, we know that because both of these columns, the y1 column and the y2 column, have the same number, 300, 300. So x is 500 and y is 300, 300 in both of those.
So now we can refer back to how we identified the variables at the beginning. So we identified x as child tickets, so let's go back to our table. X was 500 right here. So we can say that there were 500 child tickets. And y was, let's go back to the table just to look, y was 300. So we can say that our adult tickets were 300. What is the question asking us for? It's not asking us for adults, it's asking us for child tickets. So we can go ahead and type in 500 here.
For question 2, it asks us to assume the number of tickets sold would not change. How much would the theater have profited if each ticket cost $5? Well, there were 800 total tickets. Each one costs $5. This requires way less math. We do 800 times 5, which is 4,000. So they would have made $4,000 if each of the 800 tickets just cost $5.
So you can see that using the calculator, once we understand kind of how the calculator works, navigating it, these types of equations and problems are going to be a lot easier, and they're going to take a lot less time because we're making the calculator do the hard work for us. So 2 examples today. Good luck on your problem set.